Yo, it's your boy Mr. B bringing you some maths. And today we're going to be talking about special quadrilaterals. And why are they special? They're special because they have some properties that are always constant if there's the same kind of quadrilaterals. We saw some quadrilaterals before on the last video, but those ones were all over the shop. These ones are kind of nice and neat and symmetrical, and they have special properties, so let's take a look. Starting with the OG, the square. What's special about the square? You should be copying those down. They have 4 equal sides, so every side is the same. They have 4 equal angles, each one of them is 90 degrees, so each one of those angles is 90 degrees. And diagonals bisect each other at a 90-degree angle. So if you knew squares from primary school, this might be the new thing for you. But look, if I draw 2 diagonals over there, they're going to bisect each other. Bisect means cutting exactly in half. So that means that when the diagonals meet, they cut each other at half. So the left part and the right part are exactly the same length. And they bisect each other at a 90-degree angle, meaning the angles in the middle of the square are all going to be 90 degrees. So those angles formed by the diagonals. Cool? Alright, then we move to this guy here. You know this guy probably? Yep, it's the stretchy square, also known as the rectangle. What's special about the stretchy square? Opposite sides are equal. So it's not like the square anymore where every side was equal. Now it's opposite sides only that are equal. Angles are equal and 90 degrees. So all the angles are 90 degrees. And the diagonals bisect each other. So they cut each other in half. But very importantly, not at a 90-degree angle. Cool. Next one. We got this guy, which you might know as the flying square, also known as the kite. Now, kites are important because a lot of the questions are involving kites because they are a bit more complicated. So let's take a look. Kites have 2 pairs of equal sides. Now you see those lines that I drew on the sides. You see that the top sides have 1 line, the bottom sides have 2 lines each. Those lines are to indicate which sides are equal. So the sides that have 1 line going across, they are equal to each other. And the sides that have 2 lines going across, they are equal to each other. Cool. Kites have 1 pair of equal angles, and it's those guys over there. The other 2, very importantly, are not equal. Cool. Then, 1 diagonal bisects the other at a 90-degree angle. Meaning, when you draw your diagonals, only one of them cuts the other one in half. In this kite, it's easy to see that the horizontal one was cut in half and the vertical one wasn't. That's always the case, yeah? And when they bisect each other, it's at a 90-degree angle. So all the angles in the middle, where the diagonals are 90 degrees. Cool? Then we have the slanty stretchy square, the parallelogram. What's important about parallelograms? Well, the opposite sides are parallel and equal. There's a special way that we show that sides are parallel, which is with arrows. So those 2 sides are going to get 1 arrow and those are going to get 2 arrows to indicate that they are parallel to each other. Now, do you need to have 1 arrow on those sides and 2 arrows on the other? Yes. Any side that has the same amount of arrows is parallel to other sides with the same amount of arrows. And that's how it works. Cool? Opposite angles are equal. So the angles that are facing each other are equal. So in this case, the bottom left and the top right. And the top left and the bottom right. And diagonals bisect each other at a 90-degree angle. By now you should know what this means. And the last quadrilateral is the wonky square, also known as the trapezium. What is special about the trapezium? Not much. The only thing you need to remember is the trapeziums have 1 pair of parallel sides. Cool? Alright, let's take a look at some questions. Find the size of angle DAB. If you don't remember how to use 3-letter angle notation, go back to my video on angles in parallel lines. But the way the 3-letter notation works is we're starting from D, going to A, ending at B. So angle DAB is going to be that guy over there. Cool? Now, very importantly, I'm going to put a letter on angle DAB. I'm going to call it X. to make it easier so that you don't have to write DAB over and over again. Cool? Now, we don't have enough information here to find what DAB is. However, using properties of quadrilaterals, which is the whole point of this lesson, we can find another angle. We can find angle ABC, which is that guy over there. What's the value of angle ABC? Well, kites have one pair of parallel angles, one pair of equal angles, which are those two. So we know that angle ABC has to be equal to 105. So I'm going to put that on my diagram. Boom. Now we have enough information to find x. How do we find x here? Well, we remember that angles in a quadrilateral add to 360. The fact that those are regular quadrilaterals or special quadrilaterals doesn't mean that that property doesn't apply anymore. So that means that if I take x and I add every single angle, so 105 plus the other 105 plus 65, that needs to give me 360. From here it's easy, we collect like terms and you get x plus 275 equals 360. Take away 275 from both sides, you get x equals 85. Easy peasy. Alright, you're gonna give a go at 3 questions like always. See the question, pause the video, then come back when you got an answer. Right, off you go, pause here, come back with an answer. You should get x equals 75. One more, pause here, come back with an answer. You should get BCD is equal to 80 degrees. Final one, pause here, come back with an answer. You should get that BAD is 74 degrees. Easy peasy. Now let's look at a similar question, but now we're using a parallelogram. So find the size of angle BCD. We don't have nearly enough information here yet to find what angle BCD is. Some of you who have done angle in parallel lines, I know you know how to do this, but we're using properties of quadrilaterals here, so work with me. But what do we know? We know that opposite angles in a parallelogram are equal. That means that angle ABC has to be equal to 60 degrees. So I'm going to put that on my diagram. Also, if angle BCD is x, that means that angle DAB has to be x as well. Now we're done. We know that angles in the quadrilateral add to 360, so let's go. If I take my x and I add x plus 60 plus 60, the whole thing needs to equal to 360 degrees. Cool. Let me move it up so I have more working space here. Collecting like terms, this will give me 2x plus 120 equals 360. Take away 120 from both sides, you get 2x equals 240. Divide both sides by 2, you get that x is equal to 120 degrees. Easy peasy. Alright, 3 more questions, let's go. Pause here, come back when you got an answer. You should get that x is equal to 30. Pause here, come back when you got an answer. You should get x equals 125. Pause here, come back when you got an answer. You should get that x is equal to 50. Cool, that's pretty much it. Let's go to recap time. So, squares have 4 equal sides, 4 angles that are equal and 90. Diagonals bisect each other at a 90-degree angle. Rectangles have opposite sides that are equal, 4 angles that are equal and 90 degrees, and diagonals bisect each other. Kites have 2 pairs of equal sides, 1 pair of equal angles, and 1 diagonal bisects the other at a 90-degree angle. Parallelograms, opposite sides are parallel and equal, opposite angles are equal, and diagonals bisect at a 90-degree angle. Trapeziums have 1 pair of parallel sides. And finally, to solve questions, you're going to have to use the properties of quadrilaterals to get some pieces of missing information. And for your GCSEs, you might need to write down which property you used as a justification. Now, I showed you a couple of example questions. There can be many different kinds of questions, but the idea is always the same. You're going to use properties of quadrilaterals to give you some missing information that will allow you to solve the questions. Cool? That's it from me. Hope the video was useful. Borges out.